Hello Flame community, this is Jeff Kyle with the Flame Learning Channel. New to the Flame 2026 release is a major leap forward in color management, integrating OpenColorIO or OCIO directly inside of Flame. In this video, we'll be covering what OCIO is, how color management has changed in this release, and how to handle some of the more advanced new color management features. OpenColorIO, or OCIO, is an open-source color management system that has become the industry standard for ensuring consistent color across post-production applications. It simplifies and unifies color workflows, allowing images to appear the same whether you're working in Flame, Maya, or any other supported software. With Flame 2026, OCIO is fully integrated, making it easier than ever to match color pipelines across departments and studios. Flame artists familiar with the legacy Synergy color system, also known as SynColor, can breathe a sigh of relief knowing that this OCIO system has been designed with SynColor in mind, with familiar workflows, UI conventions, and customization options. And for anyone concerned about restoring archives from legacy versions of Flame, rest assured that there are systems in place to automatically bring back the legacy SynColor configurations to ensure all media is viewed as it was originally intended. We'll first encounter the new OCIO preferences during project creation. We'll find this OCIO config option here, where we have the option of choosing either a legacy or Flame preset, including the new ACES 2.0 color settings. These will populate the project's color management settings in the preferences, as well as restrict or expand the color management options in any color management field throughout the application. Our other options here are to copy the settings from another project or choose an explicit OCIO file. For now, I'm going to use a special context variables example config that we've customized for this video and launch the project. Once we're in the project, we access the color management settings in the Flame Preferences under the Project tab and Color Management section. If you're familiar with legacy versions of Flame, much of this might be familiar with a few new options. Input rules come into play when importing media with the color management set to From File or Rules, giving us the ability to automatically tag footage based on criteria we set here, either via a pattern, extension, or regular expression format. Moving over to the Views tab, formerly known as Viewing Rules, we have a list of all of the view transforms that can be applied in the viewport. My views come with a number of rules already filled out for me based on the config I selected when I created the project. If I create a new view and select the view transform we'll be using, you'll see that this is one of the first places we'll be seeing a big difference between the legacy SynColor and OCIO. While it will be a bit of an adjustment for those who are used to the legacy SynColor dropdowns we've seen for the last several years, the renaming of the various categories and specific transforms better aligns with the larger OCIO infrastructure. Other than that, another new feature is this looks column, modifiable per view, allowing us to set or turn off the ability to use a look with the new OCIO workflow. The Diagnostics tab is unchanged, but just past it is a brand new Context Variables tab, which is filled out with some examples based on the custom Context Variables OCIO config I loaded when I made this project. I'll go into some more detail about this in just a minute, but for now, note that these context variables are created in the OCIO configuration file, and of course would be set based on the needs of the studio and project in question, allowing for some robust customization of shot LUTs, shot looks, and show LUTs. In my case here, I loaded my color management settings from a simplified and slightly modified version of the ACES 2.0 preset that ships with Flame 2026. But if you're referencing an external OCIO config file from a server or project directory, Flame does not modify that external configuration. Instead, any customizations we make, like new input rules, new views, or reordered view transforms, are saved in a Flame-specific companion file, which lives inside our project and works alongside the external OCIO config. On the bottom right, we have a reload button, which is especially useful when we're working with an OCIO file that has been updated. Flame isn't constantly checking the OCIO file, so if we're in the middle of work and we don't want to close Flame, we can hit that reload button to rescan the OCIO file and load its contents into memory to update the color management settings. And finally, we have the option of exporting an OCIO config, similar to how we had the option of exporting a color policy in legacy versions of Flame, giving us the ability to export either a regular OCIO file, a locked OCIO file, or a compressed OCIO-Z archive file for use in transferring OCIO settings to other facilities. Now, let's take a look at how we can use context variables in a real-world example. When I created this project, I loaded a custom context variables example OCIO config, so we have a lot already set up for us. I have a timeline here that I've set up beforehand, but it's just 4 Alexa Mini LF clips, so they're tagged as such and being viewed in the default ACES 2.0 SDR view transform. To access the context variables, we'll apply a color management timeline effects to this first segment here. It can either be the source color management timeline effects or the regular color management timeline effects, but I'll use the source one for now, and I'll double click on it to make some changes. First, I'll set it to view transform, and we'll see that because of the way my color management settings are set up, the view has automatically been set to shot-based CC. This view is doing a few things at once. Since I'm working with ARRI logc v3 footage, it's customized to first apply the new context variable system to load a CDL from the file system based on the settings set in the OCIO config, and then apply the ARRI ALF2 view transform. Taking a look at the file system, here in my color management config section, my shot-based CC demo folder structure has 5 looks organized by shot. Shot 0 has no color adjustments and is our baseline, and then shots 1 through 4 each have a color correction that, in our example, will just grade the shot with a specific color wash. Heading back to Flame, once I switched to that view transform, nothing significant changed because our default context variables are set to load shot 0, which has no correction on it. Note that I didn't have to manually import anything or even navigate a file path. Flame just knew what to load based on the OCIO config. If you're familiar with the color management node, you might have noticed a new tab here on the left called Context. If I click on it, I can see all of the context variable settings we saw in the color management preferences a few minutes ago, and if I enable the context button with the blue chip, the text becomes modifiable and I can change the value of any of the existing fields here. The one that's relevant for this example is the shot field. My default project value, as you might have noticed from the preferences, is 0, but if I change it to 1, we can see right away the shot's color changes based on the look file associated with shot 1. The same goes if I change it to 2, 3, and 4. But if I change it to 5, I do get an error since there is no look or configuration for shot 5. Now, after seeing how this works, you might be thinking, that's great, but it's a little tedious to be heading into this context menu inside of color management to constantly adjust a parameter for each shot. And you'd be right. But that's where Python comes in to fix everything. Flame 2026 comes with a sample Python script located in opt, Autodesk, Flame _ the version, in my case 2026, and then Python _ utilities and examples, and the script is called contextvariables.py. This Python script looks for a segment's shot name to drive the context variable's shot parameter, parsing through a full sequence in no time to automate all of the manual steps we saw just a moment ago. It's set up to apply the color management timeline effects to the selected segment, set it to view transform and shot-based CC, and set the shot context variable to the segment's shot name for each segment in a sequence. If no shot name is set, it uses the background index to assign shot names, making it so there's very little setup needed inside of Flame, so long as all of the configuration in the OCIO config and the organizational structure on the file system with the look files is all set up accordingly. In my example here, I'll remove the color management timeline effects and confirm I don't have any shot names, select my segments, pull up the contextual menu, select examples context variables, and select add color management effect with shot-based CC, and we see the color management timeline effects is applied, the shot names are assigned, and the looks have been applied to all 4 of my shots in the sequence. Keep in mind, part of what allows this example workflow to work so well and so seamlessly from scratch is that we're relying on Flame's background segment field to drive the shot names, which is also what the OCIO config, the file system folder structure, and look files are named and set up to do, so everything is falling into place. When implementing this at your facility, you will most likely need to follow a more structured shot name system, but that would just mean that you need to explicitly name the shots based on your project's naming convention, and then everything else should fall into place. As one final note, I'll remove these timeline effects for all of these shots, but if you want to work in a way that uses gap color management above the segments for a bit more transparency, the Python script can accommodate that workflow as well. I'll add a track, add a color management timeline effects as a placeholder, copy the transitions to that newly created track, select all of the gap segments, and run the Python script again. We'll get a message letting us know that we're about to overwrite that placeholder color management timeline effects, and when I do, we can see our shots have been assigned, our color management timeline effects is set properly, and each segment has the correct look applied. Hopefully this gives you some inspiration on how you can cater this new workflow to your pipeline to make working with LUTs and looks easier than ever before. If you like these videos and you're finding them helpful, please subscribe to the Flame Learning channel and click the bell to stay notified about new content. Feel free to comment any questions or suggestions below. Until next time, thanks a bunch for watching.